So Howard, I'll put you on the spot first. Can you tell me a little bit about who VAST is and what they deliver?
Well, sure. I mean, the delegates are relatively familiar with VAST. We build a large-scale, scale-out file and object system based on the current state of the art in storage technologies. So we use Optane, we use QLC flash, and we're centralized around NVMe over fabrics, that the whole system is a clean slate design based on that new class of technology.
Okay, all right, great. And Stuart, for those on the phone who aren't familiar with Doug, tell us a little bit about Doug and what you guys do.
Yeah, so as I sort of alluded earlier, Doug has a heritage of oil and gas data processing. So we've been seismic processing and imaging services and software, and we've slowly recently been shifting into high performance computing as a service. And so in the seismic processing space, we've been building large systems, very large storage systems, huge networks, all those sorts of things. And we started to wonder whether what we've been doing was useful into other compute environments. So for a little while, we'd been building some of the largest compute environments in the world, and now we're making those available through a cloud environment.
Oh, that's exciting.
Yeah, it's quite interesting. Transitioning from having your whole environment being an internal system to having a reasonably externally facing system has meant some changes, and that led us into considering VAST and using VAST as our storage solution, and then, of course, Intel Optane and QLC flash.
Sure.
Stu, being a little over-modest, has left out the part that Doug runs some of the greenest data centers in the world, including the immersion-cooled servers in the upper left corner of the slide.
Let's see, I think I have an even better picture of that. Check this out. Yeah,
so we started down the immersion cooling route, and we developed our own immersion cooling solution, which we've rolled out now. We've got several, must be 300 or 400 tanks rolled out globally at the moment with all of our servers in it. We've been one of the big drivers of immersion cooling globally. And as part of that, we've pushed all the vendors to support immersion cooling, including Intel and their flash products. They may not know that they support immersion cooling, but certainly we throw everything in.
Yeah, no, that warms my heart, because before you joined, I was telling some of the other panelists that my background is actually thermal mechanical, and I spent my first few years as a design engineer doing liquid cooling systems for HP. So I saw that and started drooling. All right, so Stuart, I understand your journey from spinning disks with Lustre to VAST. It actually started years ago. Tell me more about that journey and how you got to the solution with VAST and Optane.
Yeah, so Doug's been a very, very large user of Lustre for a very long time. I mean, we started using Lustre in the very early 2000s when it was a relatively new product. And we're still using Lustre to this day. Our CTO, Phil Schwann, was one of the founders of Cluster File Systems that started Lustre. So we have a very, very deep background in that space. But the reality was it was no longer meeting our needs. We needed a full flash solution to support our workloads, to support our users. And we could have done it as a self-supported option in Lustre, but we started looking around at what might be available. We thought surely storage has moved on in close to 20 years, and we discovered VAST. And that really is a 5,000 kilometre overview of where we've been. We've loved, I must say, moving to Flash. I totally buy into I've been watching Flash for quite some time, and there's always been this mantra around when it was going to overtake spinning disk, and I think we've sort of hit that now.
Oh, that's encouraging to hear. All right, well, thanks for sharing about Doug a little bit. I want to switch over to you, Howard. Share with us a little bit about the VAST architecture and what makes it so unique in this all-flash era.
Well, the primary thing that makes it unique is cost. That VAST is designed to bring all-flash performance to costs that people are used to paying for spinning disk systems. And there are a couple of keys to that. The first is that we use QLC flash from Intel that's low in cost, but has endurance challenges in an enterprise environment. And we solve those endurance problems and many other problems using Optane SSDs. That the architecture that we use, that we call DACE, for distributed shared everything, for disaggregated shared everything architecture. I'm going to be beaten tonight for that one. Makes the protocol servers on the front end stateless. And all of the metadata and system state is immediately written to persistent Optane. We don't stage anything in DRAM. That has advantages for scaling for things like data reduction, where we don't have to have a limited amount of DRAM to keep a dedupe metadata catalog in. But more significantly, it adds to resiliency because the front ends are strictly replaceable. That just wouldn't be possible without being able to access Optane over NVMe over Fabrics. The combination of those two technologies makes the Optane SSDs close enough to the processors and the front end servers that we don't need the DRAM cache, and we don't need all the complexity protecting the DRAM cache creates.
Hey, Stu and Howard. I mean, HPC workloads have been predominantly, I'll call it bandwidth organized types of workloads. It's always gigabytes per second and things of that nature. Are you seeing these sorts of solutions supporting that sort of workload fairly well?
Absolutely. So one of the things that we desperately wanted from any new storage solution was bandwidth. We have tens of thousands of servers beating away on the file system 24 hours a day, 7 days a week. You know, we don't measure our flash in terabytes. We measure our flash in multiples of petabytes. And it's all active. And so bandwidth for us is incredibly important. Surprisingly, with VAST, you get an incredible amount of bandwidth from a 2 or 4 RU form factor. It delivers on bandwidth. It has incredibly low latency. I mean, with RDMA over Fabric, we're getting incredibly low latencies to our storage, and we're getting, you know, the bandwidths that we're used to seeing with our Lustre solution. So, no, bandwidth's great. I would challenge you a little bit, though, to one of the things that's happening in the high-performance computing space is that the workload's changing. As newer users are coming on board, they have less experience. They didn't evolve with the computer. So they don't think about just dropping their memory on disk and then rereading it back in at a later date. They're actually doing way more sophisticated data access, way more sophisticated usage. And so latency to your storage is starting to become, you know, critical. And then,
yeah, I mean, so a lot of things we've started seeing in the HPC space turning to AI as a rather than modeling, you know, flows and stuff like that. They're using AI to try to, you know, bypass a lot of the modeling, but the workload there becomes more data intensive rather than compute intensive. Is that what you're seeing as your customers as well?
That's correct. And going back to your bandwidth point, though, the other thing which happens with the bandwidth, when you have tens of thousands of servers hitting a storage system, your I/O to the storage system looks effectively random, just like any other sort of machine learning or bioinformatics workload that's now appearing. But yeah, we're seeing a vastly different I/O workload compared to our internal traditional signal processing workload, which was obviously very ordered, aggregated writes and all those sorts of things. Much more seek bound. We're seeing users on our VAST system do completely different things. They're changing their relationship with data, which is difficult to explain, but in a lot of the spaces, people used to compress data. You know, people used to tar it up so they didn't have a billion files sitting on the file system and trawling through lots of little files. That's all moving away now. You don't need to do that anymore. You can completely change how you access the data on these large clustered global file systems, which has not been really possible in the past.
So you've seen these like increase in basically bandwidth demands. What have you done to solve those problems of creating those or reducing those storage bandwidth demands between nodes that you've got on your systems?
I mean, we just put in a bigger network. I mean, the reality is, we run a very, very large 100 gigabit based fabric. So, it's not we have hundreds of 100 gigabyte switches, 100 gigabit per second switches. We connect them up in a fat tree style arrangement, and we have enormous amounts of east-west bandwidth, enormous amounts of bandwidth onto our storage. I mean, for us, a typical day, we're doing, many hundreds of gigabytes, not gigabits, but gigabytes a second of I/O to our storage 24/7. And it soaks it up, no problems at all.
So my question is on the backend more than in front end. Maybe Howard can answer to this one. But so if we have no bandwidth limits in the front end, I mean, scale out and everything, do we start to have, other limitation in the backend? I mean, the PCI bus, is that enough with all these flash memory devices, Optane and, IOPS, write amplification, whatever? I mean, where is the limit now?
We do bottleneck in PCIe lanes in the enclosures. That's the limitation. And to the extent that each enclosure has 200 gig connections to the fabric, and we've moved them to separate slots so that we have more PCIe lanes to serve the network. So when we can move to PCIe 4, then that's going to double our bandwidth. And we have some other tricks up our sleeve.
Yeah, I was just going to mention that PCIe 4 is coming, of course, and a lot more PCI lanes are coming in the next generation servers that we've heard from.
But I mean, fundamentally, it's a cluster. So you can also just scale wider on the back end as well.
Yeah, especially the way you guys wire switches.
Yeah.
But I was thinking about the efficiency of the entire architecture. I mean, we have new bottlenecks now, so that was my point.
The truth of IT is you never eliminate bottlenecks, you just move them.
You just move them, that's right.
No, I was just going to point out that the architecture is quite flexible, and you get to a certain size of scale out with VAST, and it actually becomes more reliable. You often hear in the storage space people saying, once you get to 14 terabyte disks, you have to start having 3 disks redundancy, et cetera, et cetera. Once you start getting to a certain size, you have to have complete hardware redundancy. You have to be able to drop a back end server, drop a front end server, and not have a problem. And once you get to certain size in VAST, you get full redundancy every single place in the system. And so, you can drop a back end server and the system copes with that. You don't lose data. You bring it back up, it rebuilds it, and away you go. So it's very, very impressive.
Thanks for that comment. So, Allison, I wanted to bring you in with at least a question, because you saw this from the Intel perspective, and I know you were one of the architects. Tell me a little bit more about the attributes of Optane SSDs that made it the right product for VAST's architecture and their universal storage system.
Yeah, I think that one of the things that I especially love about the solution is that it's pairing that QLC with the Optane, and Howard touched on this a little bit, but QLC drives are not just cheaper TLC. They really do have different characteristics. Not only are they lower endurance, they have much slower writes. You have to sort of treat them with care in order to get that high capacity, low cost out of them. And Optane makes such a good pairing because that's where the Optane characteristics, which, we really have very limited indirection system. You're not doing all the background defrag activities. You can do all this high write throughput, makes it perfect as that write buffering that's helping you shape the writes that are then moving on through to the capacity storage. And then maybe I'll make one comment about the importance of these, as we're moving to these higher speed networks, especially 100 gig E and PCIe Gen 4. One of the great differentials there, you start to see like our Optane AlderStream driver P5800X that we just launched on PCIe Gen 4. We can start to saturate that 100 gig E network with just 2 of those drives versus you start needing 6, 7 of those drives as you start looking at NAND and NVMe.
Oh, interesting. Didn't know that. I learn something every day. Thank you. All right, so I will close out this section. I'm gonna put you on the spot again, Stuart. But tell me how this has made your life better or easier.
I mean, fundamentally, the better architectured your storage is, the easier your life. There's less support, there's all sorts of things. So by shifting to VAST, we got all these side benefits. We got lots of great bandwidth, we've got low latencies and all these sorts of things. But we also, it turns out, got a much, much lighter support burden. We've seen, anyone who's used to Lustre and run on Lustre is used to seeing the emails, oh, it's running a bit slow today, or, one of the servers is having this problem. We've done away with all of that. That's been an amazing transformation, that the IOs occur, they never go slow. We have complete separation of our customers. So a customer beating away on the file system, as long as we stay within the bandwidth, the actual physical constraints of latency and bandwidth, our customers don't interact with each other. They can be beating away on the same storage system and not see each other, not be affected by each other. And that was critical to offering a cloud solution. We wanted to be able to offer every single customer the hundreds of gigabytes a second we can see. But trying to do that with a spinning disk and the head seeks that go on and all those sorts of nasty things is near impossible. You add more customers, you effectively start reducing their performance of their storage, whereas with this VAST solution, that just doesn't happen for us. The Optane can keep up. It can deliver plenty of bandwidth. You are limited purely, in essence, by the performance of your network and how many network links you have.